Okay, and so before we start today's presentation, I just want to give the land acknowledgement. We acknowledge that Ryerson Library is in the Dish with One Spoon territory. Dish with One Spoon is a treaty between the Anishinaabe, Mississaugas, and Haudenosaunee that bound them to share the territory and protect the land. Subsequent indigenous nations and people, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. We are fortunate to have the privilege of working on these territories. You may be joining us today from other places, near and far, and we also acknowledge the traditional owners and caretakers of those lands. We have, sorry, as we make this acknowledgement, we are dedicated to continuing to increase our own awareness, understanding, and conscious actions on this land. Okay, and with that, I hand things over to Jay and Aaron.
Thanks, Jimmy.
Thank you, Jimmy. Much appreciated. So, to start off with an etiquette, so there will be a Q&A at the end of the session. So we would definitely appreciate if you mute your mics when you're not speaking. Additionally, this is definitely optional. I understand that there are many different settings, such as other family members currently living in. So if this is not possible, we completely understand. No worries. Otherwise, we want this in presentation to be more interactive. So we would appreciate if you turn on your videos. But again, if you're comfortable with that. But during the presentation, you guys are feel free to use the chat and ask any questions in advance. And finally, we are recording these talks, but if you have some reasons that you wish not to be recorded, we will stop the recording. So just let us know, okay?
So my name is Aaron Tucker. I'm a sessional instructor at the Ryerson English Department. I've been at Ryerson in some way, shape, or form now for nearly 15 years. Currently, I'm a member of the Ryerson University Collaboratory, where talk is based from. And I'm a research fellow at the Center for Ryerson Digital Humanities. I'm also doing my PhD in cinema and media studies. And I have to acknowledge the people who are helping fund that PhD, the Alaya Scholarship, the Vista Lab, and starting in September of this year, the Bombardier Shirk. So my graduate work studies the cinema of facial recognition software, in particular between the triangulation of citizenship, mobility, and crisis.
And hello, my name is Jay. I'm a third-year master's student and supervised by Dr. Neil D. Bruce. And when I first joined in the lab, I was more interested in data analytics, optimization, the whole mathematics side of machine learning. But after working at the Collaboratory, I had a chance to grow and work with different amazing researchers such as Aaron, and I soon found myself that applying deep learning into different kinds of media, whether that it would be images or videos and text. I found that I had also passion for those as well. So just that's a bit about me. So what we're going to discuss today is called unrecognizable. One of the topics that we're going to discuss today is unrecognizable sources, and this is the current final product. We are still actively working on this. There's going to be a demo link at the end of the day, so you guys will actually have a chance to play around. But more importantly, we're going to talk about what is unrecognizable sources, and why are we working on recognizable sources, and earlier works in the collaboratory that built the framework for unrecognizable sources such as the photogeny series and this criminal does not exist. Additionally, we're going to discuss about GANs, generative adversarial networks, how they work. I have very high level overview of how those models actually get to be trained, and finally, we're going to touch upon what is the potential disruptive value for synthetic or fake data. So, what is unrecognizable sources? Well, Me and Aaron actually took initiative about this project, and we both realized that there are a lot of technologies related to facial recognition, such as, and that could be applied in many different areas, such as driver's license or airport at the passport, mugshot, or even social media. They are social media applications. But there weren't many, especially there weren't many resources for non-technical individuals to actually understand these FRT. We're gonna call facial recognition technology as FRT technologies, and we believe that we need some kind of open source toolkit that which is able to disrupt and desire for accurate identification and verification by creating and utilizing maybe open sourcing synthetic database, as well as creating an API for anyone such as artists to use facial recognition FRT technologies within their research or applications. So also this is a part in progress for SHIRK Insight Grant application between Ryerson University and York University and OCAD University at the Public Visualizations Lab. So more concretely, what we aim to do with unrecognizable sources is not only create a open source API and also tutorials for non-technical individuals such as artists or everyday person, but we also aim to generate a database or data set that is resistance of extractive and non-consensual data practices. This can be more or less understood as generating fake data, and we're going to touch upon how we do that. Additionally, we wish to visualize the biases ingrained in data annotation practices and actually show what those biases will look like when we visualize them. So altogether, we wish to make a set of tools for non-expert as well as non-technical individuals to further explore and understand the vulnerabilities of this technology, and for them to incorporate this technology within their research and application. So just to touch up on the computer science perspective, how my perspective changed as a computer science student. When I first began my graduate studies within the computer science, it was more or less always about beating human expertise. And what that means is that in a very simple format, getting the highest accuracy, doing it fastest, doing the best, getting the highest accuracy, whether that's on classification, segmentation, or any kind of format that gets the paper published, or aka so-called state of the art. However, after working with Aaron and expanding my viewpoint on this, viewpoint on artificial intelligence, I quickly realized that there's a huge gap between the researchers, what the researchers' papers, motivation behind researchers, and the actual implication of this technology that gets to be used in the wild, especially when we consider people from different socioeconomical status. For example, when a darker skinned individual, or for a darker skinned individual, the recognition system is more likely to predict a violent prediction, such as having a handgun. But for lighter skinned individuals, it's more or less lesser violence, such as monocular. So these kind of gaps really do exist within our world, and it was pretty shocking to me in a computer science perspective.
Yeah, and I think when I think back to when Jay and I first started collaborating together at the Collaboratory, and I think about where we are now, I'm actually really proud at how badly I've polluted Jay and moved him over out of some of his computer science kind of arguments and rhetoric, and started to reposition some of that. The example he just showed is just one example of both this combination of the flaws within computer vision and their struggles to recognize darker skin, but then also the inscribed racial data in racial and racialized uh, uh, problems within data annotation practices, which we're also going to talk about today. First, I know a number of us are kind of researchers or teachers, and maybe we're looking for a few other resources to share with people. So these are some things that I found inspirational, and Jay and I have both found inspirational. This piece from Shu Li Chang, 3 by 3 by 6, it was just at the Venice Biennale at the Taiwanese Pavilion, and it's this really fascinating combination of 3D facial recognition, AI, and the internet, and it's sort of looking at queer immigration and its place in the world and its interaction with technologies like facial recognition and basically kind of this ecosystem of surveillance technologies. It's a really fascinating work and worth looking up a little bit more of. The next piece, Hammer, Lonzo Hammer's piece. He, as an artist, he's fantastic. He does a number of really interesting work. The one that we wanted to draw attention to, because it definitely influences unrecognizable sources in a big way, is a piece level of confidence in which he would have people come and stand in front of a camera. Their faces would be scanned, so you can see that in the photo down there on the left. And then their faces would be matched with one of the photos from a database of disappeared Mexican students. So it's sort of using facial recognition not to match you to yourself, but to match you to a face like yours. And it's through that connection and that matching that we get this sort of affective combination of these two things. And I think a really telling critique of the violence and enacted on people like the disappeared Mexican students. So this project's really fascinating to us as well. ImageNet Roulette, which I would argue is kind of more looking at data annotation practices, but is also really useful. Trevor Paglin has a wide range of artworks kind of critiquing and pulling out some of the black box systems of FRT. This particular project, though, I think is worth lingering on. Kate Crawford and Trevor Paglin basically were using ImageNet, which was one of the very first well-annotated massive data sets that was out there, and they used it and were allowing people to interact with it in such a way that you could see some of the biases that were ingrained in the data annotation practices of this database. Unfortunately, the project is down now because it was too popular and they couldn't keep it up on a server, basically. But I wanted to come back to it because I think it's fascinating. And then you can also see there's an essay there called Excavating AI, which is written by both of them. That is a really good primer and expands on a lot of things that Jay and I are talking about here that I think is really useful for students and for people that are maybe interested in expanding some of their knowledge about these systems. And then this is relatively recent in the last few months. There's a collective called Indigenous AI, and they recently put out a position paper on Indigenous protocol and artificial intelligence that, again, if you can follow that link there, I think it's a really important contribution to discussions around artificial intelligence. There's another essay by some of the same authors of this collective called Making Kin with Machines that is also really powerful. Basically, it's talking about the ways in which indigenous epistemologies and relationality might help us better understand some of the ethical quandaries that are present within current applications of artificial intelligence. And what I like about this particular collective in Making Kin with Machines is that they're always future facing. It is always about futurity and imagining how things could be different by way of some of these indigenous epistemologies. So Jay and I have done a number of work that kind of leads into the unrecognizable sources, so we thought we would touch on it. In particular, we've kind of taken up two streams almost simultaneously, one of which is looking at the content of facial recognition databases, like who is in the databases. And that's sort of what the Photogenie project that I'm going to talk about is about. And then the second parallel track is about data annotation practices. How do we annotate the faces in the databases, and how does manipulation of that annotation change things? But this first one, I wanted to talk about how prototypicality gets built into facial recognition technologies by way of their databases. So this started a series of short film works. Each piece is about 4 minutes. And so far I've done about 12 of them I'm calling it the Photogenie series, basically in combination with a bunch of cinematic theory from Walter Benjamin and Bella Balaz and Jean Epstein about like the cinematic face in close-up. And Jean Epstein called it photogenie, this idea of being kind of photogenic. And so I'm really interested about the role of celebrity faces in the history of facial recognition technology. And there's actually a long history of it. It begins with Takeo Kanade's work. So, oh, sorry, can you go back, Jay? At the 1970 World Expo in Osaka, he gave the first public demonstration of facial recognition technology. He called it computer physiognomy, and we can kind of, again, think about what physiognomy means in the 19th century kind of characterizing of faces. He openly is calling it kind of computer physiognomy, and the demonstration at the World Fair was people would come in, they would sit down, they'd have their photo taken, the photo would be scanned, and your face would be matched to one of 7 celebrities. So you might be matched to Marilyn Monroe or Elvis Presley. I believe Winston Churchill was in there, John F. Kennedy. So basically using this system to match you with a celebrity face. So the idea of photogeny and celebrity faces has been present right from the beginning.
And as brief history lesson is that when it comes to celebrity database for facial recognition technologies, there has been right now there's multiple databases, but there is a long history of using celebrities as initial data sources. One of the most famous is called the iBug facial landmark dataset, which measures the 68 specific key points of the face region, such as where is the nose, where is the mouth, where's the left eye, where's the right eye. And another interesting thought around this is depending on the availability of the data set, the technologies that get to be the FRT technologies that gets to be built around it could also have different implications, such as if the data was collected on North America, it will the built up on technology will most likely work on North American individuals, but not much outside from there.
Yeah, and so this is sort of how prototypicality gets built in. And Simone Brown, this is a really fascinating and powerful book called Dark Matters. And she, in particular, talks about the ways in which biometric systems are built around a certain white normativity, whereas whiteness is made normative. And the white body, and in this case, the white male face most predominantly, is made the default face. So Brown argues that this prototypical whiteness is one facet of the cultural and technological logic that informs many instances of the practices of biometric and the visual economy of recognition and verification that accompanies these practices. If you go to look at some of these celebrity face-based data sets, you will see that they are predominantly white-skinned individuals, and most of them are men. We can talk about, like, again, some of the data practices, like why is it useful for computer scientists to use celebrity photos, right? And this idea of consent and celebrity faces as public resource. But one of the arguments I wanted to pull out was this idea of that these sorts of practices are how prototypicality gets built and how certain faces are more likely to be recognized than other sorts of faces. And often this gets embedded in the machine learning training materials. If you wanted to learn a little bit more, Joseph Pugely's book, Biometrics, Bodies, Technologies, and Biopolitics is excellent. And then I'm also expanding this into a chapter in a collection called Face Forward, which is forthcoming from Edinburgh Press in 2022. So we thought we'd show just a little bit of a demo of Photogenie. So Jay, I'll let you play it and you can kind of look at it there. So basically what I did is I took faces from the iBug data set, and Jay and I built a bunch of different scripts that we could process this footage. This actually comes from the Hunger Games. And really look at the types of faces that are present within these data sets and force people to really examine the types of faces that are there. So you can see I've kind of slowed down the footage. I've very deliberately tried to choose clips that are focused on the face as this balance between both the photogenic or photogeny and the types of prototypicality that get built into these systems. I think kind of artistically, I'm also drawing from Warhol, who is exploring many of these tensions within celebrity faces at exactly the same time that Kanade is building this computer physiognomy in 1970. The fact that both Warhol and Kanade are using Marilyn Monroe and Elvis at the center of their technologies and their arguments about kind of popular imagery, to me, is really fascinating. And I think more than anything, Warhol's screen tests were really influential on this, in which he would just tape for minutes at a time celebrities just looking into it. So again, we kind of have like two ways in which our work is operating. So one, on the content of facial recognition databases, and second, how are images within those databases, whether they're in machine learning or they're in databases themselves, are being annotated, and what sort of assumptions are built into those annotative practices, and how further prototypicality is built. So Jay's going to lead us through a little activity here.
So on your screen right now, on the top screen, you'll see Jay is sharing your screen, and on the right section, which you guys will have an option. If you click that option, there's going to be a drop down, and I believe there's going to be a tool called annotation tool.
Or just called annotate, yeah.
Oh, annotate. And when you click on it, you'll have multiple options, but we recommend using the text box option and actually trying to annotate and actually trying to guess this individual's age, gender, and race. And from the get-go, we want to mention that this individual actually does not exist. It's a fake generated image from GAN. But while you are participating in this exercise, we also wish that you are aware of the assumptions that you make from just the visual information that you get from the photo. So why are you letting this individual be that age, that gender, and that race?
Yeah, so we were hoping that you might take a bit of time and try and annotate this image and reflect on the types of information you're using in that annotation. Just again to repeat Jay's instructions, because for some of us maybe this is brand new. Jay did a great job, but there's a green button at the top. You're viewing Jay's screen. To the right of it, it says View Options. If you click on that and go down to Annotate, it should bring up a brand new bar. And if you click on Text, you should be able to annotate this image here. And oh, there's a number of people doing it. Great. So this is honestly how a lot of data annotation is done, right? It has to be done by hand. There's not really a lot of good automated annotation systems, especially for faces. People have to go through and annotate these faces. This annotation, especially if you're using systems that were built 10 years ago, they were faces that are annotated 10 years ago. Those annotations are not updated, right? So I want you to keep this in mind. We're going to return to this later on. But I want you to think about, one, the types of assumptions that you made doing this, but two, how did this make you feel? Did you feel good annotating this face? And what parts of this did you maybe feel good or less good about? And there is going to be a chance to talk with our mics on a little bit later on about this, but we'd like you to think about it for now.
Okay, so should we move on?
Yeah, let's move on. So I think there's a clear thing on your annotate. Yeah, great. Okay, so can you make this full screen again, please, Jay? Thanks. So as we go through this again, unrecognizable sources is kind of taking on two different things at once, right? Like we're kind of looking at the content, but this is about the data annotation practices. And we really wanted to focus on content, consent, and classification. So who is in these data sets? Did they give consent? And then how are we classifying in these many different ways the faces within this? We wanted to point to a number of different sources. Again, if you're an educator or you want to learn more about this, I found these sources really, really excellent. Pasqualani and Yoler's The New Scope Manifested, which Pasqualani's is really, really good and talking about AI and the way in which biases get inscribed in there. I also wanted to point to some texts that are, I think, pointing more towards solutions in some ways. We have a collection edited by Lisa Gittleman called Raw Data is an Oxymoron, which is excellent. And then a more recent text from Yanni Lukacs called All Data Are Local, which I've found really, really arresting and compelling. And then if you're kind of looking for some texts that set the groundwork for these later texts, Boker and Starr's work sorting things out is one of the ones that most people reference back to.
There's another great resources that if you want to take a more deeper look into the practical maybe regulation and regulation in some terms of regulations. This document is Facial Recognition Technology in the Wild. It's a white paper, and researchers such as Eric, Visant, and Jamie and Joy actually not that only discusses the disturbedness, what kind of what how this FRT technology can disturb different individuals from different socioeconomic status, but they actually go to the federal government and say these are the rules that there need to be in place in order to minimize the damage and to better the world. Better the world. Michelle, better the world in the future for future generations.
Yeah, and the previous slide there, I think what it does in proposing a sort of FDA style system for algorithms is saying like you can go and look at a box of cereal, let's say, and you have to list the ingredients. That's essentially what they're proposing for algorithms, that each algorithm has to in some way show the data provenance. Where did this data come from, right? And then it has to make clear what are the different parts of this algorithm. Is it talking to other algorithms, which is one of the things that, you know, if you have a facial recognition algorithm that's then talking to some sort of social media data scroller, then we should know that. That's basically what they're arguing. And it's an argument for transparency. So all of these have come to help us shape this idea of unrecognizable sources in which we are generating, annotating, and utilizing fake data, synthetic data, produced by GANs, generative adversarial networks.
And one of the benefits to actually use fake data is that there's decoupling of the individuals, the real identity of the individual, and how their face looks within the photo, like such as information about me, my bank number, my phone number, etc. For fakely generated images, there is no personally identifiable information. Hence, that decoupling is one of the reasons why we actually wanted to use these kind of fake data, because we believe that those aspects of synthetic data are a great value. Oh, that I was just talking about the yep. This.
Yeah. So the face. Oh, sorry. Let's just go back for a second, Jay. The face is the following slide, please. Yeah. So the face has long been kind of a place in which biopolitical tactics have operated, going, you know, in particular photographic tactics, all the way back into the 19th century, in which you're kind of using these different things in order to sort different populations. One of the sorting that I'm most interested in is citizen and non-citizen, and the ways in which we might use facial recognition technologies to really quickly and efficiently sort citizens from non-citizens, and then what does that mean kind of from a political way. to call somebody a citizen and not a citizen, the resources that are attached to it. So what we're trying to do is get into the middle of that kind of nexus and disrupt facial recognition's desire to match a face with an identity. What happens with like the Lonzo Hammer piece? We suddenly say we can't match these, or we're going to match you to different types of faces, and we're disrupting and kind of short circuiting some of the identification verification mechanisms that facial recognition technologies really depend on.
And now we're actually going to take a look at GANs, how they work in a very high level abstract, and how we train those models to generate synthetic faces that you guys are seeing now. So at the beginning, let's just say we have two machines. Two machines. One is called G and other is called D. So G stands for generator and D stands for discriminator, but we'll call G and D for short. And for now, we're gonna forget about D. We're only gonna look at G. And we're gonna give this G an instruction called draw a face. Now, initially, like a baby, G will be horrible at drawing faces. So maybe he or she will draw something like this that kind of resemble a face with some kind of mouth, etc., etc. And that's okay because we're gonna take this drawing and we're gonna go to D. But before giving this drawing to D, we're gonna sample a real image, a person of a real image. In this case, a face of Aaron, and we're gonna give that to D, and ask one very simple question: which one is real? Real is in which photo contains a real individual's face, not a drawing, but a real one. And in this case, it's pretty obvious to tell that the image in the above is fake. So it's gonna correctly classify that that's Aaron and that's drawing, and we're gonna take that result and go back to G and ask one question: can you do better? You did well, but your brother D told you that maybe it doesn't have a nose and having a red hair. It looks very fake. So G's gonna take that feedback and he or she's gonna draw another drawing that looks more realistic this time. Now, of course, it's getting better, but it didn't do well. So, but it's okay. We're gonna take that image again, back to D, and this time we're gonna present another real image. This time, an image of me, and ask D the same question: which one is real? Now, although the image that G draw looks more realistic than the previous one, it's pretty easy to see that the above image is a fake one. Now, this process gets done over and over and over again, maybe up to 40,000 times or 400,000 times. And eventually, G will actually get really, really, really good at drawing so-called fake faces. So good that it becomes indistinguishable of real images. In a very high-level overview, this game of I guess catch and mouse. G trying to trick D and D trying to tell which one is what G have produced or drawing G have produced. This is the way how GANs are being trained. And continuing on, our project called This Criminal Does Not Exist actually used this framework of GAN to visualize what kind of biases that could be within a certain set of data set.
Yeah, so if we go back to the previous slide, this is a project called This Criminal Does Not Exist. And this is actually a project in which I wanted to look at mugshot databases, but I didn't want to just take those mugshots out and, let's say, in a conference presentation, present it. I wanted people to know what sort of faces were present in these databases, but I didn't want to replicate those faces and the problematics with it. Again, in terms of mugshots, you're more likely to have a mugshot if you are in a population that's more likely to be arrested. So if you're over policed, you're going to be overrepresented in a mugshot database. And so you're just perpetuating a lot of these biases that eventually, by the time they get into a database, are already pretty ingrained. So how do we talk about these databases without actually pulling the actual photos out of there? Well, I had this idea about, like, can we use a GAN to generate faces from these databases that would be representative of the faces within without actually being the faces within? So I've been thinking about GANs as a data visualization technique. So my work then began initially with Kieran Ramnaran at the DME lab at Ryerson. He's a recent computer science grad. His specialization is in deep learning, and he and I have been working on GANs, and we're continuing to actually collaborate. Uh, Basically, what Kieran and I did is we hand built a GAN, and we sort of went through one of the tutorials, and we just sort of said, can we build a GAN from the ground up? And for me, that was quite interesting because I wanted to learn the guts of it and how it works. And I was trying my best, even though I'm a non-coder, to understand what's happening at each level. So for example, I saw a question in the chat, how does G learn to do better? So when G generates a face and gives it to the discriminator, when the discriminator passes it back to the generator, it also passes back information about how it can generate better faces. And that's how the discriminator slightly improves. And then by giving that over to the discriminator is improving. And so you're kind of going back and forth, improving both these things at once. So for this criminal does not exist, we use the meds and meds2 database as a way of, so these were people who had multiple encounters with American law enforcement. And so it was people with multiple mugshots in this law enforcement. Tellingly, they were all dead. So you couldn't actually get consent from these people. So not only is it kind of like a liminal population of mugshots, but you're also using deceased people so that they can't argue about being included in this data set. So as you can see, the images here, they weren't crystal clear in Kieran and my sort of initial work here, but I really liked the initial faces that came out of it, because as you can see, and even from the slide that I was looking at previously, you don't need to go back, Jay, that what we essentially built was a black male face generator, because that was the face that was most common and that the GAN was thinking was most representative within there. So could we go to the next slide, please? Yeah. So the next stage was Jay and I using StyleGAN2, which is a really robust, previously built GAN architecture that has generated things like this person does not exist. And it's actually quite useful. So Jay and I said, okay, instead of building this GAN from the ground up, we're going to use a pre-existing GAN, and we're going to give it the same database. And as you can see here on the right, this is kind of the faces that it was generating after about 150,000 iterations through the GAN. And so what we want to say here is that we built a proof of concept, and we're sort of stopping for now in terms of wide public distribution. This research is really sensitive, and in conversation with scholars such as Eve Tuck, I think we're only going to go forward when we start, after we've had some conversations with some of the stakeholders and communities that are going to be most affected by this research, including local activist groups, faculty at Ryerson in York, and the Ontario Law Commission. So right now we're sort of proof of concept and prototype stage, but I think we've proven that GANs can be a really useful data visualization technique for representative elements of what's in the database. So again, how does this bring us back to unrecognizable sources? Well, this is a synthetically generated data set. All of these faces are not real people. So already we're trying to, instead of using real people, what happens when we build a facial recognition technology out of synthetic data? And we use that as a baseline, as opposed to, let's say, a social media profile that's attached to a person, a Flickr account that's attached to a person, et cetera, et cetera. So Jay's going to take us through another activity, basically revisiting our previous one.
Thank you, Aaron. Now, knowing all of the things that we discussed above, again, please go up to on the top of your screen. You're going to see that Jay is sharing his screen, and on the left you will see an option. And if you click and drop down the options, you will see an annotate tool. And please give it another shot of annotating this individual's age, gender, and race. Again, and please be aware of the assumptions that you might have while making those predictions. And in this time, we are also going to ask you guys to do another annotation at the next
Well,
slide.
let's let them do this one
No,
first,
yeah,
and then
but
yeah,
first.
yeah, and then we'll transition to the second one. Oh, great. So again, like in terms of assumptions, what kind of cues are you using as a way of saying what type of face this is, right? Is it the hair? Is it the eyes? Is it the mouth? Is it glasses? Is it what looks like a hat? We should also mention too, just like the previous one, this is not a real person. This is a synthetically generated person. I also would like you to reflect on like the category that you are typing under race, right? What do you, so if the bulk of these are, let's say, Asian, what do you consider Asian? What part of the world, right? The racial categories are present in almost every single facial database. And one of the ones that I think actually, when you start attaching this category to faces, really highlights the problematics with it. Great. So we have a pretty wide range of ages. We have somebody saying masculine, non-binary. So you're already getting at some of the things, right? Like if we only have a binary system within our annotation process, there's going to be some faces and bodies that this leaves out. And there's no option, let's say, under race to also have multiple entries. You have to be kind of one thing. What does it mean to categorize somebody as one thing?
Also, please be aware that we're gonna have a discussion session, and how did the question of age, gender, race to annotate make you feel when we asked to do this exercise? Should we move on?
Yeah, let's clear this and then we'll move to the second one.
Sure. Oh. Now this time, please try to annotate or guess this individual's salaries per year, criminal history, and sexual orientation. Now these are a different set of questions that we ask. Also, please be aware of the assumptions that you might make, and we will have a chance to discuss how this made you feel and what kind of assumptions that drive you to the final conclusion.
And keep in mind too, these are questions that are often asked of facial recognition technologies, or that facial recognition technologies are tasked with.
Oh, I see a wide range of salaries. 65.
And again, think about the assumptions, right? I'm going to remember this if glasses alone get you a higher salary, what this might mean for me.
White collar crime. I guess that could mean
Well, it just means like tax evasion, embezzlement.
tax evasion. Ah.
Yeah, like kind of quote unquote victimless crimes, which of course they're not victimless.
Interesting.
So again, think about how, for me, these questions are really, really fascinating when you give them to, let's say, a facial recognition technology. Quite often how they're given, let's say, to a facial recognition technology is another algorithm. So when you build an algorithm around criminal history, and then you give it to a facial recognition technology, and you have those two algorithms or those two machine learning systems connected in some sort of way, then you get this like really robust algorithmic ecosystem that has almost like two sets of separate data annotation practices that are conflicting. So we want you again to think about this. And for those of you that have the ability to turn your mic on and you're interested in talking about this, Jay was going to lead us through a bit of a discussion.
So after doing all the annotation process with the two faces, the female and or not the female, but the first individual and the second individual. Just reflect on how did the annotating exercise made you feel, and what kind of assumptions did you actually had when it comes to predicting the age, gender, and race? Was that different between salary or maybe criminal history? And what if we ask you to name the likelihood that that person that we present was a criminal? How would that make you feel, and what kind of assumptions would you have? And finally, since this is what Era mentions, that this is generally how the facial annotation practices are being done within the industry. Individuals have to just think of their age, gender, and race. How might that process create biases within the technology? So we'll open the discussion board now. Should we?
Yeah, absolutely. If there's people that are willing to turn their mics on, even just that first question, like viscerally, emotionally, how did you feel having to assign these different categories to these different faces? Is there anyone that's willing to share?
I can be the first. I
Sure,
found
Tang
that
Min.
yeah, Hardy. Uh, what a great session. Congratulations.
Oh,
So
thank you.
my personal feeling, the first one is easy, a bit easier than the second one.
Mm.
And so I don't know if it's because he already told us the second one's fake, kind of not a real face. But first one, my personal feeling is easier to tell than the second one for whatever reasons. That's my feeling.
Yeah. And how did you feel when you were asked to say, like, is this person a criminal? What sort of crime? Like, kind of squishier data categories.
It's really hard to say. I think it just obviously the second person looks like a little bit like a white collar worker, like at least from the face that just from all past probably kind of experience, and but obviously we always have our own bias, right? And so that's my first impression, right?
Yeah. So we can think about then, how do our own biases get filtered into the data annotation biases? If we have a human annotating this data, how does that person's, decades of lived experience factor into how this annotation takes place?
But the other comment I have is when you talk about crime, like it's very hard to define what kind of crime, because like if you're high tech, like engage high tech crime, it's not that obvious, but it's in some ways even more dangerous.
Right. Well, one of the things that I'm most interested in, and I see some people like Michaela, I'll get to you in just half a second, is a lot of the times these systems assume guilt. So you'll notice we said, like, what crime has this person been given, and you have to kind of guess, right? And to me, these technologies almost kind of like assume guilt first, then you go through the algorithm and you're proven innocent. And that to me is a really problematic dynamic. I saw Michaela,
Lisa.
you had your mic, and then Lisa as well.
So it was actually me who wrote the first one as white collar crime. And I did that as an experiment. I did that to see how many, like, whether that like identification will trigger other people to assume that this person is a white collar criminal. Like I didn't have that bias, but I was like thinking, how does it feel? And also, do these databases work in the way that when people annotate the faces, do they see like what were similar faces annotated like, So it's kind of like the bias is kind of like a learn effect, like I've seen this face that is similar to the face that I'm annotating, so yeah, he might be like, somewhere in Facebook. I think Facebook, everybody is a criminal, so I just like put white collar crime, so that was an interesting experiment for me.
Yeah, that's great, thank you. Lisa, you had your hand up.
Yeah, well, I'll just add first, I also put white collar criminal, but that's because to me, the last face we looked at, it looked like that person was wearing colored leather, like a leather jacket and a fancy hat, which to me read as a rich person, right? So, but I don't know, I think, yeah, it felt, quite bad to be asked, oh, what are your inherent biases about people, and to assume guilt. But like, I was thinking about the fact that these are things that we can't possibly know and can't ascribe. And in certain ways, it would be kind of comforting, and it's been a long project for people to want to identify what criminals look like, but we can't know what criminals look like because criminals look like normal people, right? Like that's something that comes up with discussions of Ted Bundy or someone, where they say, oh, he's so good looking, no one could ever know, right? But criminals look like normal people. And sexuality, what does that look like?
Yeah, and so I think what we end up doing, especially in an algorithmic environment, is we use other algorithms or we use other data enrollment, right? So we'll use like a mugshot database and we'll connect it to a facial recognition, and we can think about all the, again, like based on policing, who's most likely to be in those databases. Or let's say you take, you pull a bunch of photos off of a gay dating site, right? And you use all of those photos, suddenly you're generating essentially like trying to generate some sort of category around sexual orientation. And then what happens when you bring that over into a facial recognition thing or a shopping site or anything, right? And it's interesting too, thank you, Lisa, like clothing are one of the main triggers. So if we, there's within facial recognition, there's so-called cooperative and non-cooperative. So cooperative would be something like a visa profile where you sit and you have your photo taken, and non-cooperative is just CCTV and scanning, right? And we can think about the different biases that might be built into a cooperative environment versus a non-cooperative environment. Arun, you had your hand up.
Hi, Aaron. Yeah, I kind of like hearing what I just heard. It feels like this is a recreation of 12 Angry Men over Zoom, which, and so you can see how it's like the semiotics of it, and then like what our experiences are, how we bring into it white crowd, and how it can have a cascading effect on it as well. The questions where our own like personal histories and it's like what we bring to the table and how we infer from what we see of it, like where we have to play Sherlock Holmes. Those are the questions that are kind of like the scarier ones. The other ones are the more, what you see is what you get kind of questions don't have as much impact. But again, that kind of tells us it's like what kind of racial histories and backgrounds, how does that affect it? What kind of, like, we don't know the ability of that person, with a face is like what other, if they have any disabilities or such like. Yep. So, yeah, like how that would impact how we read what we read of it. If the person had a disability, would we give that person that much salary? So yeah, I mean that, and would we ascribe them to have criminal traits so as well? So again, I'm kind of like, what do we miss out on? What do we infer from, when we're playing detective?
I think that's exactly right. And when you're speculating or you're relying on other algorithms to feed you the information or other data enrollment things, like let's say driver's license, right? We can then think about, okay, well, what are some of the assumptions in those systems as well? The other thing that I find really, and then maybe we'll move on and we'll kind of take up more questions in the Q&A.
Michael actually had his hand up.
Oh, Mike had his hand up. Oh, sorry, Mike.
That's okay. No, it's fine. Really, it's. I had the same feeling I think that others did in terms of sort of discomfort. But I think the other thing that occurred to me while I was doing this against all those categories is, we were asked to sort of choose and to analyze. But I think at the end of the day, I was judging, and there's sort of a judgment going on here that increasingly made me uncomfortable. Because as others have said, we were judging on information we didn't have, or frankly, information we couldn't even use if we had it. It wasn't appropriate in some way. So I think that was just one of the comments I wanted to make.
That's great. Thanks, Mike. And I think too that judgment, when you then have to put that judgment in a very stable data category that can't hold two things at once or can't hold simultaneous values at once, it has to be this one thing. That also creates for me, like I have been annotating our synthetic data set right now and I hate it. It's icky. I don't like it, and I don't like actually ascribing a lot of these things because it feels judgmental. I think that's exactly the right word.
Also, I want to make a confession. I think Michelle, I really appreciate Michelle pointing this out. For the second person, I was gonna say white, but I saw people starting annotating him as Asian, and for whatever reason, I just stopped that. Yeah, so it was a very interesting happening. That at least that happened for me.
Yeah. So again, please keep asking questions. We're going to go till probably 11:30ish, so we'll have time at the end. But we do have a few more slides to get through, including this one. So this unrecognizable sources, we just wanted to do a little bit of data provenance first. So unrecognizable sources, we're using a database of fake faces. We're putting that database through a GAN and making more fake faces. Now, this doesn't get rid of the biases entirely, but we're trying to see if this distances us from maybe those initial inscribed sort of prototypicality. So the database that we're using is called the generated photo database. So for us, it was 37,000 synthetic faces. Their documentation is not super clear. I don't know what they use to produce those faces. But if we look at the style GAN architecture, the GAN that we use, I suspect that the generated photos use some of the similar ones, including the aforementioned ImageNet. There's also a database called Celebrity HQ. So our celebrity faces are coming up again. And then there's a bunch of object databases that I'm guessing are being used in the discriminator phase to say like, this is a face, this is not a face. What is this thing, right? And then you pass it back to the generator. The other thing, and this has kind of been an ongoing thing over the year, is before you can identify and verify a face, you have to be able to detect a face. And most Python libraries, different things like that, are just really not clear about what they're using for face detection and where it came from, let alone how that then feeds into it. So that's also an ongoing project. But Jay is going to walk us through a little bit of a demo on the state of this prototype for unrecognizable sources at this point.
So this is the live link that I'll paste it on the chat, and anyone can come in and use it as they want. And I'll give you a simple tutorial on how to use it. So if you actually visit this website, I'm going to turn off my camera for now. You're going to see a website that looks something like this. Can anyone see me?
Yep, I can see it.
And when it's ready, it's going to, please give it a moment for the system to boot up. You will be able to take a selfie of yourself, but we're not going to save any images, so please don't worry about it. And after that, the system will find all of these images are synthetic data, so they aren't real people. And the annotations are done by Aaron himself. But again, there is no real individual that looks like this. He is at age of 29 and Asian, or 25 and Asian. But what the system does is compares your facial features to the synthetic faces that we have, and it displays you in a very elementary format of the features that this individual have, such as their age, race, their expression, are they happy, are they disgusted, their gender, etc., etc. Now, for me, even if I look at different, good. Well.
Oh, it changes a little bit, the probability. So left to right is like most probably you're this, second most, third most.
Oh wow, I got her as well. But yeah, it's usually all for me. It's these three individuals always. For you, it will be different.
Yeah, and the database actually, this is sort of very, very beta. There's only 30 faces in the data set at this point. So it's, oh no, this one actually only has 24, right, Jay? Mm-hmm. Yeah, so there's only 24 faces in there. But you can sort of see the like kind of physiognomy here, where facial recognition technology is not matching you to your exact identity, but it's matching you to faces that look like your faces. So eventually, and Jimmy says it's the same three faces for him as well, right? And you can start to see how faces get categorized by these sort of systems, right? So what Jay and I are doing is we're making this tool available, but we're also going to post the code so that people can go in and on GitHub and play with it. We're going to make it so that you can take your own database and drop your own database in there and then have people kind of like the hammer piece, the Lonzo hammer piece, be able to do both of those things at once. And yeah, we're just trying to think about what artists and thinkers might be interested in using this technology for, basically, and trying to make it as low bar and entry as possible. So we're also going to be really heavily annotating the code that we put up on GitHub as well, and trying and putting up video tutorials alongside. Here's how you do this. Here's how you do that. Again, we're at early stages, but we at least have something. The last things that we'll kind of like bring up, but we're not really going to linger on, is inevitably when I go and give conference presentations or whatever, and I want to talk about synthetic data and facial recognition, people want to talk about deepfakes. And people, I think, are really concerned about them. And people are wondering like what the future of it might look like, synthetic data, right? We're kind of making an argument in this talk, like synthetic data can short circuit these systems, but I think they're also really powerful things to reinforce power in a lot of ways. So we have been looking at deepfakes as a way to be documentary reenactments of events. So how might we use deepfakes to like reenact something from the past? And then second, create potential futurities, counterfactuals, alternate histories with deepfakes. So the, sorry, can we just go back for a second? The first project is called He Said, and this is, we kind of built a deepfake of Trump, and what we did is we substituted old audio. So it's not like we're making Trump say anything that he never said before. We fed it the Access Hollywood tapes, and then we kind of like puppeted it so that it looks like he's speaking the Access Hollywood tape. So what this does is for us, it provides a sort of documentary reenactment for something that doesn't have video footage. So what happens when you get Trump in the Oval Office, let's say, speaking these kind of horrible things? The second project is kind of more counterfactual, alternate history, futurity. We took the speech that John F. Kennedy was to deliver the day that he was assassinated, and we had him speak it with a deepfake. And again, it's kind of saying, well, what are some of the counterfactual histories? What are some of the alternate histories here? Right now, we realize these examples are not particularly strong, and we would invite people to kind of play with these tools in more diverse ways, I think. But we just wanted to kind of prototype and just do things that we had a lot of. There's a lot of footage of Trump. There's a lot of footage of JFK that we were able to use kind of readily at hand. Yeah.
So thank you for listening to our talk. If you have additional questions, our email is up on the screen now. Also, Aaron's going to be holding a workshop at the Ryerson Center for Digital Humanities on oil research creation on November 3rd. So for more details, please reach out to him, and more details going to be announced soon. Thank you.
Yeah, and I'm thinking that workshop might actually